Hey guys, in this video, in the last video, we talked about left Riemann sum and right Riemann sum, and how how those two gave us two different answers. So we're gonna go ahead and talk about something that's called the midpoint sum. Letter D: estimate the distance traveled by the car during the 12 seconds by finding the area of two rectangles drawn at the heights of the midpoints. This is called midpoint Riemann sum. So let's go up to our graph. Let's go ahead and erase all these rectangles. Okay, and then that's it. All right, so for midpoint, we have to rely on the midpoint of the base, and we were instructed to find the area of two rectangles. So I'm going to split this into two parts. Here's one part, so this is going to be one rectangle somewhere there in the middle, and then another rectangle here. Now, when you're using midpoint, you don't rely on an endpoint of the rectangle, you rely on the midpoint. So I'm going to draw a line going up like this, and then going straight to the right, straight to the left. Notice that in midpoint, we have both an over and under approximation. If you notice, the right side of the middle of the rectangle is an under, the left side is an over. So it kind of balances out some of the error, but not equally. So I don't want you guys to think it's an equal amount of error on both sides. So now we have two rectangles. Now here's the tricky part. What are the bases of these two rectangles? 6, because you're getting the 3 plus 3. That makes a base of 6. That makes a base of 6. And instead of relying on endpoints for the heights, we're going to rely on the midpoints that we chose here. So we're going to do 6 times 37 plus 6 times 54. So let's go back to our area is distance, which is 6 times 37 plus 54, and that is 37 plus 54, 546 feet. Let's compare this with the other two answers we got. The first answer, we got an under approximated answer. The second was an over approximated, and this looks like to be something in between. And midpoint seems to be more accurate. As you can tell, there was a lot less error compared to the other two Riemann sums. Now let's talk about the last Riemann sum method that we'll be using today. Estimate the distance traveled by the car during the 12 seconds by finding the areas of four trapezoids. This is called trapezoidal sum. Okay, so for trapezoids, you have to remember, what is a trapezoid? What is the area of a trapezoid? Trapezoids usually look like this. They have two parallel sides with two other sides that are not always the same equally in length, but they connect the endpoints of those two parallel sides. The area of a trapezoid is base 1, base 1 plus base 2 times whatever the height might be, times the height all over 2. Very similar to what an area of a triangle looks like. But we don't form horizontal trapezoids when we're taking the trapezoidal sum here, because if you notice in my graph, we draw our rectangles in a vertical orientation. So let me go ahead and redraw this area, or this trapezoid, in a vertical orientation. So this is going to be the base, this is going to be height 1 and height 2. Okay, this is the base, whatever this base is, these two should be the same. So what is the area of this kind of trapezoid? Well, it's very similar. It's going to be base times height 1 plus height 2 all over 2. Okay, so let's go ahead and draw this first so we can see how it works. So let's remove all this stuff here. Okay, so we're gonna have four trapezoids. So this is the way I draw my trapezoids. I just draw the lines going straight up like this. Draw every line going to each endpoint. I'm sorry, to each height. Now, for every two dots, you're gonna just draw a line going straight to each one of them. This, like that, like that, and like that. Those are my four trapezoids. Now they all look like they connect, but it's just because of the way I drew it. Okay? If you were to zoom in, I am going to have some error. Now, do you notice that this is going to be a lot less error than left, right, and midpoint sum? So we're probably going to be able to trust this a lot better. So a lot more. So let's go ahead and find the heights. The heights are 37, 45, 54, and 65. This is one trapezoid, two trapezoid, three, and fourth trapezoid. Now, the trick to finding the areas is that each trapezoid is going to be depending on both the heights and the base. The bases are 3. So let's just formulate the area of the first trapezoid. You guys have your sheet of paper in front of you. So this is going to be easier for you guys to follow. I'm probably going to have to be going up and down. So the area is the distance, and then it's going to be the area of the first trapezoid, which is the base times the height 1 plus the height 2 all over 2 plus area of the second trapezoid. Now it's going to be the second, those two heights. So it's going to be base 37 plus 45 all over 2, and then base 45 plus 54 all over 2 plus the base 54 plus 65 all over 2. Okay, now you could find the area of trapezoid 1, trapezoid 2, trapezoid 3, and 4, and then add them up, or you can use your special factoring skills. What do you notice in common out of all of these areas? They all have a 3 and a divide by 2. So I'm going to go ahead and factor out 3 over 2. And now I have 30 plus 37 plus 37 plus 45 plus 45 plus 54 plus 54 plus 65. Now, if I could, I can go even further. I have two 37s, two 45s, two 54s, and one of each of the endpoints. So I can write this as 30 plus double 37 plus double 45 plus double 54, and then finally plus the last height. So you guys are going to get so good at this. You guys are not going to start here. Once you guys have enough practice, you're going to be able to just start with this equation, and all it becomes is a calculator problem. And these are calculator problems, unless they're like super easy numbers. Don't worry about not using the calculator. And then 65. And then, okay, so the parentheses I calculated to become 367. And then I got to multiply that by 3 and divide by 2. So times 3 divided by 2. And I get 550.5 feet. Now, I'm going to trust this answer more than I'm going to trust all the other answers, because it is obvious that left Riemann sum was under, over, midpoint was okay, but it looks like just from a visual perspective, trapezoidal sum provided the best, the most accurate approximation. And that concludes today's lesson. So I'll leave you guys with the second page for you guys to do and to practice. So I'll see you guys in day 2.